Okay, welcome back. Today we're going to solve a complex, unfamiliar question. We have the scenario, question 19, paper 2, QCAA, external assessment 2022. So let's solve for method number 1. So what is the question? Question is a research organization plans to use a drone, drop scientific instrument vertically. So that means we drop vertically, drone here. So we might call this as X. Distance, vertical distance X. So initially it was stationary. So that means X0 is 0 and the velocity also 0. So then drop to the ocean. So this is the ocean. The acceleration falling instrument can be modeled. So this is the acceleration. So we got A in relation to time was 9.8 minus 1.3 VT if I in relation to time. And the velocity is VT. All right, so we don't know. But we give you two values for VT. One is, so the VT must be, if you speed hit ocean, reach at least, so means minimum is 20, but less than 50, because otherwise, so minimum should be 50 to activate the device. But if you more than 80 or 50, the sensor will be damaged. So we need to determine, what is the X. What is the maximum X so that we don't damage, we don't hit that 50 speed. And what is the minimum distance from the height from the drone to the ocean? That speed will be 20. So we need to find those values. All right, so let's do method number 1. I'm going to use the AT in relation to time. So that's the formula we got. So I'm going to put a, because AT is dv dt, derivative of the velocity with respect to time. So then we're going to oscillate. So move that one to the left. So move left. So make sure we simplify. I'm going to times by 10 both sides. So make sure I put a 98 minus V equal to 0.1 T. So then integrate it. Both sides. All right, now we have got the formula is log 98 minus V equal to negative 0.1 T plus C. Now we're going to decide what a C is. So we're given the initial value, velocity when time to 0 is 0, so we substitute 0 into the function. So C is log 98. So therefore, my formula for the velocity with respect to time is log that. So I'm going to undo that. I'm going to undo the log. So we're going to move around things around. So now we've got, so eventually, so here is 0. Now we're going to move things around. So it'll be negative here. So final result for velocity with respect to time is, that's the formula. Now, why is negative? Because I moved to the other side, become negative index. All right, I'm going to go substitute because we need to decide what is the time taken so we can work out of x. So first, I'm going to find a time when the velocity hit the water 20 meters per second. So I'm going to use a graphics digital camera. So substitute into this equation. So we know the formula can be used for graphics calculator. Save your time. So don't use a manual because otherwise it'll take a long time. So then you substitute next 50 into the formula. So you got two different times. Then you can find, actually we call x. Because we want x1, x2. So when the time is 2.283 seconds, I'm going to integrate it. The velocity, this is the velocity function integrated. So from zero, because it starts stationary, to hit the water is take 2.28 seconds. So I'm using GDC. So don't forget, use the G graphics digital calculator to find that the integration is 23.3 meters. Then the x2, when the integrate from 0 to 7.138 seconds, so the answer will be 199.5 meters. So same as GDC. So therefore, my x, sorry, it should be x. So the distance should be between the launch hit to the water. If you want to be speed in 20 meters per second, you need to that distance. If you need a 50 speed, 20 speed, respectively, so you got two different range. So this is a range from the height you need to launch the drone. So this is method number one. Now method number two, I'm using, instead of acceleration in relation to t, I'm going to in relation to the vertical height. So I'm going to say acceleration with respect to the height, which is a vertical height above the ocean. So therefore, I'm going to use, when you differentiate A, so you have to use the composite chain rule. So we become V. So differentiate the V with respect to X. Then, so that's the dV dx. So this is actually, V is dA dV and dV dx. So dA dV is V, all right, velocity. So therefore, I'm going to move things around. So this is the V divided by that equal to X. Then I'm going to times by 10 both sides. Then I'll switch over. Instead of 98 minus V, I'm going to V minus 98. So I'll change to negative. So then I'll do the fraction. I need to make a minus 98 and then plus 98. So therefore, the left-hand side become two fractions, 1 plus 98 divided by V minus 98. So that's the integration to be easier. So now I'm going to integrate at both ends. So V plus 98 times by log of absolute value V minus 98. And negative right-hand side is plus C. So don't forget to decide what is C. C will be substitute V equal to 0 into it. So C is 98 times by log 98. So my velocity with respect to X is given by this oh, sorry, given by this equation. Then I'll substitute v equal to 20 into the equation. We will find that the vertical x1 is 23. Also use the GDC. Second one, substitute v equal to 50. We'll get x2 is 199.5. So the answer will be same as the method number 1. So this is complex, unfamiliar question because this is we are solving for the differential equations. So this is a very good question. Show you how to solve differential equations. Thank you for watching. I hope you enjoyed the video. Can you give us a thumbs up if you do? And also don't forget, subscribe to the channel. Just hit the bell so you can get a latest video. I'll see you next time. Bye.